Hello everyone. In this session, we are going to see some important and basic introductory part regarding to the coordination chemistry, which is most important for the bachelor students. Okay, so we will start from the dative bond. What is meant by dative bond, which is also known as the coordinate covalent bond, which is the base for the coordination complexes. Okay, so this is the basic type of the bond which is responsible for the coordination complexes. So these are nothing but the covalent bond that forms when the both electron come from the same atom. So we have the electron donor and we have the electron acceptor. So in concern with the electron donor, it must possess the pair of valence electron. So whatever the pair of valence electron from the electron donor, it is supposed to transfer towards the electron acceptor. So that sharing of pair of valence electron from electron donor to electron acceptor is responsible to show the dative bond between the electron donor and acceptor. Okay, so we can define scientifically that coordinate bond or dative bond is a special covalent bond where one atom donates the both electron in the shared pair, while the other atom accepts into the empty orbital, forming a strong and directional link common in the coordination complexes. Okay. Furthermore, the understanding of dative bond can be done with the help of these examples, that is formation of ammonium ion, in which whatever the nitrogen present in the ammonia, it has the pair of valence electron, and that pair of valence electron is supposed to transfer from nitrogen to empty orbital of H plus ion. So there is formation of dative bond between the nitrogen and the hydrogen in the ammonium ion. Okay, a similar kind of example in concern with the formation of ammonium boron trifluoride, in which we have the ammonia, we have the boron trifluoride, and in this case, whatever the ammonia present in the ammonium, nitrogen present in the ammonia, it has the pair of valence electron. Okay, so the pair of valence electron from the nitrogen, it's supposed to transfer towards the empty orbital of the boron in the boron trifluoride by forming the dative bond between the nitrogen and boron. Okay, there is another example, H3O plus formation, in which the oxygen present in the water molecule, that is H2O. So it has the pair of valence electron, and that pair of valence electron, it transferred from that oxygen to the empty orbital of H plus. So there is formation of the dative bond between the oxygen and nitrogen, which form the H3O plus. Okay, so and this is the base for the coordination complexes. Okay, so we will discuss now what is meant by coordination complexes. These are the chemical compound actually, which consists the central metal atom or ion. Usually it is metallic one, and there are surrounding molecules or the ions, which are generally known as the ligands or complexing agents. Okay, so there is a dative bond between the ligand and the central metal atom. So overall, the chemical compound which contains the central metal atom surrounded by the complexing agents, which is known as the ligand, is known as overall coordination complexes. Okay, and these are the much more vital as compared to the simple double salts or the simple salts. Okay, so this is the example that is present view. In this case, we have the central atom Fe surrounded by the 6 cyanide ligands. Okay, so whatever the number 6, that is the number of ligands, is revealed as the coordination number, and the overall placement of this central metal atom and the ligand, it is in the coordination sphere. So whatever the moiety present outside the coordination sphere is known as counterion, which can be cationic one or anionic one, and the sphere outside the coordination sphere is generally known as the ionizable sphere. Okay, the structural arrangement of the coordination complex can be further understood by seeing this example, in which we have the central metal Fe, which is surrounded by the 6 ammonia ligands, and we have the counter ions outside the coordination sphere. So this is about the overall coordination sphere. Okay, and the charge present on the coordination sphere, it is overall charge on the coordination sphere, and with the help of this charge as well as the charge present on the counter ion, we can reveal the oxidation state of the central metal atom. Okay, and the further understanding of the oxidation state as well as the coordination number is done with the help of Varnastali, okay, which is the next part we will see later on. So before that, we must know why coordination complexes are important, okay. So now currently we have the emerging areas of the energy, emerging area of medicinal, environmental science, material science, okay. And in every aspects currently, these are the complexes which are important one due to their variety of properties, physical chemical properties. So in concern with the reaction, that is hydrogenation reaction, we have the Wilkinson catalyst, which is important one, which acts as catalyst, okay. Then we have the G-salt for the olefin coordination. Then we have the cisplatin, which is widely used in the chemotherapy, that is anti-cancer drug. Then in concern with the MRI application also, gadolinium based complexes, which is the lanthanide one, and it has the number of paramagnetic, it has the paramagnetic layer, okay. It is due to the number of unpaired electron present or associated with the gadolinium complexes. So that's why it is important in concern with the MRI application also. Then in concern with the environmental remediation to remove the heavy metal ions present in the wastewater, that is we can say the hardness of water can be determined with the help of such complexes. Then in concern with the material science, fabrication of sensors, electronic devices, regarding to photochemical and photophysical applications. And then regarding to specifically that I mentioned herein, that is in concern with the environmental remediation. So regarding to analytical chemistry, we have the EDTA based complexes which are responsible to determine the hardness of the water. So hardness of water is nothing but the amount of calcium, magnesium, or any kind of heavy metal ions present in the water sample. Okay, so we have to determine that hardness in terms of the calcium or magnesium. So how we can done that? With the help of forming the complexometric titration, or by doing the complexometric titration, in which we have to form the chelates with the chelating agents. So EDTA is the one of the chelating agent. Okay, so what is the chelation actually? So these chelates are nothing but the coordination complexes actually, but whatever the ligand utilize to form that complexes, those are responsible to form ring-like structure in the complex. Okay, and if you have the complex with the ring-like structure, so generally they are the chelates. Okay, so ligands are the polydentate actually. They are able to form the ring-like structure, mostly four-membered, five-membered, or six-membered, and so on. Okay, and in concern with the agriculture also, as I mentioned, metal chelates. Okay, so these are the some important aspects regarding to high coordination complexes are. Also, in next case, the significance of complex salt can be done by differentiating it with respect to double salt. Okay, so in concern with the definition, we can see that the double salts are the compounds which formed by the crystallization of two or more simple salts in the fixed stoichiometric ratio. And regarding to complex salt, already we have the definition, that is the compound which contains the central metal atom or ion bonded to the ligands through the coordinate bond. Okay, so we have the respective examples in concern with the complex salt as well as double salt. Dissociation in water, we can say that the complex salts are much more stable as compared to the double salt, because they does not completely dissociate. Okay, while the complex the double salts, they dissociate into the constituents. Okay, due to, and this is due to the actually strong coordinate bond present in the complex salt. So this is also associated with the stability in the solution. So we can say that the double salts are stable in the solid state, but in concern with the solution phase, they are they acts or they behave as the individual salts, while the complex salt retain their structure in solid as well as solution state. Regarding to bonding, already we know that double salts, they possess the ionic bonding, while the complex salt possess the coordinate covalent bond. Okay, then we have the respective examples already we discussed, and they have the respective applications also. Then we will see what is meant by ligand actually, and the types of the ligand associated. So ligand, it is an ion or the molecule which binds with the central metal atom or ion through the coordinate covalent bond or the dative bond. Okay, so whatever the ligand we have, it acts as an electron donor, and the central metal we have, it acts as an electron acceptor. So there is a dative bond between the ligand and the central metal atom, and the ability or how ligand attaches to the central metal center in the coordination complex is revealing the hapticity of the ligand. So it can be monohaptate or the bihaptate or the dihaptate and so on. Okay, it is related to only the number of sites attached with the central metal atom. If only one site is attached, it is monohaptate. Okay, so it is monohapto. While if you have the number of sites attached with the central metal, then it is polyhaptic. Okay, if it is only two, then it is bihaptate or dihaptate. We can say that. In connection with the three sites attached with the central metal center, then it is trihapto. Okay, and so on. We can reveal. So regarding to types, we have the monodentate ligand, bidentate, tridentate, poly, and so on. Okay, so basically we have the two types, monodentate and polydentate ligand. So regarding to monodentates, these are the molecules of the ions which has only one site, and it will form only one bond with the central metal center at a time. Okay, it has only one site to get attached. These are the examples. So halides are the monodentate ligand. Water molecule is the monodentate ligand. Ammonia is the monodentate ligand. Cyanide is the monodentate one. Okay, regarding to thiocyanate, it is a kind of different type of the ligand. We will discuss that one. It is known as ambidentate ligand. Okay, we have next slide there. Then regarding to bidentate ligand, for example, ethylene dimer or oxalate ion. So these are the type of the ligands in which they have the two donating sites. They can form two bonds at a time with the central metal center. In connection with the tridentate ligand, we can define that the ligands having the three donating sites and they can form the three bonds with the central metal center, and so on. Tetradentate, hexadentate. Okay. So regarding to hexadentate or pentadentate, these are the polydentate ligands actually, and they are able to form the ring-like structure in the complexes. And if already we discussed the metal chelates or the chelates, so these are the complex. Those have the chelating agents, that is the ligands. Those are able to form the ring-like structure in the complex. They provide the high stability as compared to the simple salts also, that is complex salts. So polydentate ligands, generally they are able to form the ring-like structure. So there is a point of chelates, that is chelation. And whatever I discussed regarding to thiocyanate in the monodentate ligand, so it is a type of the ambidentate ligand. So ambidentate ligand, a type of the monodentate ligand that has two different donor atoms, that is donating site, but at a time it can only form the one bond with the central metal center. Okay, even though it has the two donating site, but at a time only one bond is possible. Okay, so best example, if the metal center binds through nitrogen, then it is isothiocyanate. So, and regarding to the thiocyanate, the metal center binds through this sulfur. So the same ligand, but it has the two donating sites, sulfur and nitrogen. Okay, and the name it based on the by which side actually it is binding with the central metal center. Okay. Yes. So for this session, we will stop here. So we discuss the ligand, the types of the ligand, how the types of the ligands actually associated with the central metal center and how they are differentiated. And important point of the ambidentate ligand also discussed. The difference between the double salt and the complex salt also we have discussed, and the formation of the T2 bond also we have discussed. Okay, so for this session we will stop here and in the next section we will discuss the one theory regarding to the coordination complexes. Okay, thank you.